Here I have a Raspberry Pi 5. It's in the official case and has the official fan with the big heat sink. I'm going to plug in a breadboard connection to it onto the GPIO assembly. We're going to do an electronic build of a Morse code generator. Here I'm booting into the desktop. We're going to go over to the programming editor, Genie. This is a Python code I wrote for controlling the electronics or through the GPIO assembly. I'm going to type in a phrase here to have it signal the Morse code for. You can see the red is a dash, the yellow is a dot, the blue signifies the end of a character, and the white is the end of a word. I'm going to change the speed here and bring it up to about the speed of an actual Morse code. Quite a bit faster now. The library being used to communicate with the GPIO pins is called GPIO 0. Works on the Raspberry Pi 5, 64-bit version. The Pi 5 is a different architecture than previous Raspberries, so the legacy libraries no longer work with this. I'm going to do a DIR on the library to show you all the different functions it has inside it. This will control most electronics that comes in the kits for building breadboard assemblies. You can also work on your Python code in Visual Studio Code. What's important about that is it has a debugger inside it and Genie does not. So you can actually step through your code and look for bugs. Here I'm down in the terminal part of the app and I'm typing in a phrase for it to transmit. Open up this terminal a little bit so you can see it a little better. We're going to go into the Linux terminal and look at the actual source code. I can see it's not executable, so I'll use chmod to turn it into executable. Now they're all green. Okay, here I'm going to run the file from the command line, type a phrase into it. And there it's running. We'll take a look at it in the Nano editor. So this gives you 3 options for editing the code. I don't use this one too often, but it's handy if you want to make a quick little change like to the speed of the program. Okay, I'm going to change out one breadboard with another one I was working on yesterday. This one has an LED light on it, button. Normally the way these work is you push down on the button, the light comes on, you let up, it goes off. But I wanted mine to stay on when I pushed on the button and stay off when I pushed on the button. I wanted to operate like a light switch. So here I push it and stays on. Off. Now if I hold it down, it doesn't do anything, it just stays on. Take my finger off and it stays on. Off. Just like a light switch. I'll show you the code here. It's not very much code at all, just that much code. Wait for the next key to be released was the key to making this work like a light switch. Here's a look at the Sunfounder Raphael kit. It comes with quite a bit of electronics. There you have the LEDs and diodes and transistors. Some other electronics, motion detectors, light detectors, servos, motors, a keypad, a lot of stuff in here. And GPIO 0 communicates with all of it. There's some wires for, connecting to your breadboard. It comes with an extra breadboard, a ribbon, kind of handy. The GPIO 0 documentation is online. It's up to, I think, version 2.0 right now. Take a quick look at it here. I'm in the Chromium browser on the Raspberry Pi. Pretty swift. There's some of the documentation, some of the recipes, your pinout. So it's all here. The nice thing about the Python interpreter is you can use it to do other things and communicate with the GPIOs. Here I made an amortization for loans. 7.1% for 5 years. Shows me all my payments for each month. This isn't my car loan, luckily, but it does give you an idea. You can just do any type of loan, house loans or anything in it. Or you can use it to do something as simple as play a game. Here I'm just playing dice. And last, the Raspberry Pi 5 will now play PicoChess 3.2, which is the reason I got into the Raspberries. This has over 50 engines on it, including Stockfish 16. So it works really slick and will beat me every time at a higher level.